In this video, we're going to learn how to perform multiplication in various number systems. To start, let's remind ourselves of the process in the decimal system. For this example, we'll pick two numbers that aren't too large but aren't too small either, 573 and 238. However, the product will be quite substantial. To multiply, we write both numbers one below the other, with the larger number on top and the smaller on the bottom, ensuring the digits line up according to place values. We work from the least significant digit to the most significant, right to left. We multiply the top number by each digit of the lower number, and with each successive digit, the product shifts one place to the left. This shift happens because we are effectively multiplying not by 3 but by 30, or not by 2 but by 200. This will become clearer as we go along. First, we multiply 573 by the smallest rightmost digit of 238, which is 8. We multiply each digit of 573 one at a time, starting with 3 times 8, which gives us 24. We write down 4 in the current column and carry over 2 to the next place. Next, we multiply 7 by 8, add the 2 carried over, resulting in 58. We write 8 and carry over 5. Then we multiply 5 by 8 and add the 5 carried over, giving us 45. We write down 5 and carry over 4. Since there are no more digits on the top number, we bring down the 4. Our result so far is 4584. Next, we move to the second digit of the bottom number, which is 3. As noted before, we'll start placing the result of multiplying by this digit one place to the left. This shift occurs because we are effectively multiplying 573 by 30, broken into two steps, first by 3, then by 10. Multiplying by 10 is essentially shifting all digits one place to the left. So 3 times 3 gives 9, then 7 times 3 gives 21. We write down 1 and carry over 2. Finally, 5 times 3 plus 2 gives 17. Therefore, 573 times 3 is 1719, making 573 times 30 equal to 17,190. We skip writing the 0 here as it doesn't affect the sum. Now we multiply 573 by the leftmost digit of 238, which is 2. Here the result shifts yet another place to the left, as we are actually multiplying by 200. So 3 times 2 is 6, 7 times 2 is 14, we write down 4 and carry over 1, and 5 times 2 plus 1 gives 11. Thus, 573 times 2 equals 1144. So 573 times 200 is 114,600. And again, we skip the two rightmost zeros when recording. Finally, we add up our three results: 4,584, 17,190, and 140,600. We have already covered how to add numbers in a previous video, which will appear in a suggested link. After summing them up, we get the result 136,700 374. We'll later find the binary, octal, and hexadecimal representations of this number. Next, we'll convert both factors into binary form and calculate their product. Thus, 573 is converted to 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, and 238 becomes 1, 1, 1, 0, 1, 1, 1, 0. Let's quickly verify that these conversions are correct, as multiplication is far more labor-intensive process than addition or subtraction, and we would rather avoid redoing it multiple times. After confirming that our binary conversions are accurate, we'll write both numbers one below the other, placing the larger on top and aligning the corresponding digits by place value. For each bit in the bottom number, we'll either write a row of zeros if we are multiplying by 0, or copy the top number with a shift if we are multiplying by 1. Once we've gone through all the bits in the lower number, we'll need to sum these 8 rows, or 6, if excluding rows of zeros. The simplest way is to add them one by one, but that would take longer, so we'll sum them all at once. It's straightforward as long as we don't rush. We move from right to left. In the rightmost column, we only have zeros, so we bring down a 0. Next, we sum 0 and 1 to get 1. In the third column, we add 0, 0, and 1, resulting in 1. In the fourth column, we calculate 0 plus 1 plus 0 plus 1, which equals 2, or 1, 0 in binary. So we write 0 here and carry over 1 to the next column. In the fifth column, we calculate 0 plus 1 plus 1 plus 0 plus 0 and add the 1 carried over, resulting in 3, or 1, 1 in binary. This means we write down 1 and carry over another 1 to the following column. In the sixth column, we add 0, 1, 1, 1, 0, 1, and the carried over 1, totaling 5, or 1, 0, 1 in binary. We record the least significant bit, 1, in the current position, carry over 0 to the next position, and carry over 1 2 columns over in the 8th column. In the 7th column, we add 0 plus 1 plus 1 plus 1 plus 0 plus 0 plus 1, which sums to 4, or 1, 0, 0 in binary. So we write down 0 in this position and carry over 1 to the 9th column. In the 8th column, we calculate 0 plus 0 plus 1 plus 1 plus 0 plus 1 plus 0 plus 1, and add the 1 from a previous step, totaling 5, or 1, 0, 1 in binary. We write down 1 in this position and carry over 1 to the 10th column. In the 9th column, there are these ones plus 1 more from the previous column, totaling 4, or 1, 0, 0 in binary. We write 0 here and carry over 1 to the 11th column. We repeat this pattern in the following columns, keeping track of carried and binary sums carefully. When all calculations are complete, we find the binary product to be 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 0. To confirm accuracy, we'll convert this binary result back to decimal, by summing the values on the first, second, fourth, fifth, seventh, 10th, 12th, and 17th powers of 2. Since 2 to the 17th power is not a common value to remember, we'll calculate it directly. 2 to the 12th power is 4096, and we'll continue doubling until we reach the 17th power. Calculating carefully, we get the sum, which equals 136,374 in decimal, matching the result we obtained when we calculated in the decimal system. Now, let's convert the factors from binary to octal and hexadecimal using the method covered in the video that will now appear in a suggestion. As a result, we find that 573 becomes 1075 in octal and 23D in hexadecimal, while 238 converts to 356 in octal and E. Let's perform the multiplication in the octal system. First, we'll start by multiplying 5 by 6. In decimal, this gives 30. But since we are working in octal, we need to convert 30 to octal. This results in 36, since 30 equals 3 times 8 plus 6. So we write down 6 and carry over 3 to the next column. Next, 7 multiplied by 6 plus the 3 carried over gives 45, which converts to 55 in octal. 45 equals 5 times 8 plus 5. So we write 5 and carry over 5. Then 0 multiplied by 6 plus 5 gives 5. And finally, 1 multiplied by 6 results in 6. Now we'll multiply 1075 by 5. First, 5 times 5 gives 25, which converts to 31 in octal. 25 equals 3 times 8 plus 1. Then 7 times 5 plus 3 gives 38, or 46 in octal. 38 is 4 times 8 plus 6. Next, 0 times 5 plus 4 gives 4, and 1 multiplied by 5 is 5. Now for 1075 times 3. 5 times 3 equals 15, which converts to 17 in octal. 15 equals 1 times 8 plus 7. So we write down 7 and carry over 1. Then 7 times 3 plus 1 gives 22, or 26 in octal. 22 equals 2 times 8 plus 6. So we write 6 and carry over 2. Next, 0 times 3 plus 2 gives 2, and finally 1 multiplied by 3 gives 3. Now we add up the result. In the least significant column, we only have 6, so we write down 6. In the second column, we add 5 and 1 to get 6. In the third column, we add 5, 6, and 7, totally 18 in decimal, which is 2 in octal. 18 equals 2 times 8 plus 2. So we write down 2 and carry over 2. In the fourth column, we add 6, 4, 6, and the 2 from the previous column, totaling 18 in decimal or 2 in octal. So we write down 2 and carry over 2 again. In the fifth column, we add 5, 2, and the 2 carried over, which gives 9 in decimal or 1 in octal, because 9 is 1 times 8 plus 1. So we write down 1 and carry over 1. In the final column, we have only 3 and the 1 carried over, totaling 4, which we write down. The final result of the multiplication is the octal number 412266. To verify, we'll convert this octal result to decimal and compare it with the product we obtained in the decimal system. Calculating powers of 8, we find that 8 to the 5th power is 32,768. Substituting the necessary coefficient and summing them, we get 136,374, which matches the product we obtained in the decimal system, confirming our calculations are correct. Now, let's perform the multiplication in the hexadecimal system. First, d multiplied by e equals 182 in decimal or b6 in hexadecimal, since 182 is 11 times 16 plus 6. We write down 6 and carry over b. Next, 3 times e plus b gives 53, which is 35 in hexadecimal, since 53 is 3 times 16 plus 5. We write down 5 and carry over 3. Then 2 times e plus 3 equals 31 or 1f in hexadecimal. 31 is 1 times 16 plus 15. Since the second digit in the bottom number is the same as the previous one, the result of this multiplication will be identical, so we can simply rewrite it, shift it one position to the left. Now, let's add this result from right to left. In the rightmost position, we have only 6, so we write that down. Next, 5 plus 6 equals 11, or b in hexadecimal. Then f plus 5 equals 20, which is 1/4 in hexadecimal, because 20 is 1 times 16 plus 4. So we write down 4 and carry over 1. Next, 1 plus f plus the 1 carried over gives 17, or 1/1 in hexadecimal. 17 is 1 times 16 plus 1. So we write down 1 and carry over 1. Lastly, 1 plus the 1 from the previous column gives 2. Thus, we obtain the number 214b6. To verify the accuracy of our calculation, we'll convert this result to decimal. After calculating the sum, we get 136,374, which matches the product obtained in the decimal system, confirming that our calculations are correct.